7.6 is where we're going to start looking at what we call common logarithms. And a common logarithm that we're going to use quite a bit is base 10. We've been working with several different bases, but now we're specifically going to focus on base 10 logarithms. So this is where you're going to need your calculators. Your logarithm button on your calculator is base 10. So we're going to use that to solve exponential equations and inequalities. The inequalities are probably a little bit tougher. And then we'll look at what is the change of base formula at the same time. So just to get you started and getting you to understand, oftentimes you're going to see problems that just look like this. Normally we would write it as log base 10 of 5, but since base 10 is the most common base, we most of the time just skip out on writing 10 and we just call it log of 5. So what you need to do is you need to take your calculators. I just want you to check this. Notice what it wants us to round this to the 10,000th place. All it wants you to do is to understand how do I plug it in. So you're going to look for your log button right there of 5, close, type it in. That's your value that they want you to write down. Since they say 10,000th place, you're going to need to round it to 4 decimal places. So it's going to come out to 0.6990 would be the answer that they're looking for. That's it. That's all they want, is for you to understand how do I plug that thing into my calculator. There's a whole bunch more in your book that you can do if you'd like, but that's all they're after. We're going to try and use that in terms of some problems. So you can read all this if you'd like. Really what they're after, a couple things. They tell us L is in decibels, it's loudness, sound. When we're looking at this equation, I is the intensity of the sound and M is the minimum intensity detected by your ear. So we have residents that can hear a concert that is 66.6 decibels. That's L. So we're going to say 66.6 equals 10 log of, and then it goes on to say how many times the minimum intensity of a sound detectable by the human ear was this sound if M is defined to be 1. So then I just have I over 1, and they want us to solve for I. Well, shouldn't be bad. I over 1 is just I. So we have 66.6 equals 10 log of I. I want to get the log by itself, so we're going to divide both sides by 10, leaving us with 6.66 equals log of I. And then finally, our favorite property is to convert it to exponential. Again, they don't tell you this or specifically tell you, but we get to assume that that is base 10. So we have a base of 10 with an exponent of 6.66 equals I. You can type that into your calculator if you'd like. It comes out to a really big number that you guys can write down. I'm just going to leave it like that for now. And that would be problem number 2. Probably the most important part of using common logarithms is to solve problems that look like this. 4 to the x equals 19. Most of the time what we have done is we've done scenarios that might have looked like this. 2 to the x equals 4. I don't care. Just call it 4. Where we were able to say, oh, I want to change this and make it 2 to the x equals 2 squared. Drop our bases, x equals 2. Super nice. But the only reason that worked was because I could change this so it had the same base over here. If I go to my problem, that doesn't work out so nice. I cannot get 19 as a base of 4. Maybe I could try really, really hard, but it'd be very difficult for me. So then we turn to our favorite logarithm. Logarithms allow us to solve for an exponent. And I notice that there's not any logarithms actually in here, but We can always put a log on both sides and still be okay. Log of 4 to the x equals log of 19. You can use any base, but it makes the most sense to use base of 10 because your calculators use base 10. And we can use one of our properties. Remember, one of your properties allows me to take the exponent up here and move it to the front. That was back in section 5. That was property number 3 that we looked at. So that gets us x log of 4 equals log of 19. And then it becomes like a regular equation. Log of 4 is the same thing as a number. Log of 19 is a number. You can plug it into your calculator if you'd like. If I say 5 times x equals 19, you would just divide by 5 and you'd be good to go. You're going to do the same thing here. You're just going to divide by log of 4. So log of 19 over log of 4 will get you your value. Notice it wants 10,000th place. That's 4 decimals when I plug that in. So I'll show you one of them on my calculator. I'm going to go log of 19. Make sure you close it. Divided by log of 4 gets me that value. 2 point, not going to be able, it's going to go away as soon as I write it in there, but it's going to come out to 2.1240. I got to round that up. So 2.1240. You can actually take that, plug it back into your original 0.1240, and you should see it's pretty close to 19. Might not be exact, but it's pretty close. So that comes out as your value.